Good afternoon, everyone. Today we will have a lecture on steel structures. So, as today we are having the first lecture on steel structure, so we will have a short review or we will have a short introduction on the various concerns regarding steel structures. So, steel structure basically you have already seen the various structures in nearby which has been constructed because it has been an alternative view for the construction work. Nowadays, steel structures it is commonly used for various concerns. RCC structures are also used, but as RCC structures are expensive, therefore we can have a steel structures also. So steel structures nowadays it has been most commonly used in various construction works. So today we will have a review or we will have an introductions on the various concerns regarding the steel structures. Steel structures basically it is having various advantages as well as disadvantages. Okay, so steel structures while erection point of view, while construction point of view, steel structures plays it is fast in constructions, whereas in RCC structures, that is reinforced cement concrete structures, it takes times for constructions, whereas steel structures in a short period of time it has been constructed. So steel structures, it is having advantages or it is also having disadvantages also. So we will have today we will see the introduction regarding the steel structures. Okay. Next is we will see the evolution scheme for the steel structures. So what is the different evolution scheme for this? So we'll see the evolution scheme of the steel structures. So here there is near about in evolution scheme we will have, sorry, evolution scheme. So it is having a university exams for 80 marks, in which it is having a college internal assessments for 20 marks. In this way it is having it is totally for it is for 100 marks, whereas there will be a practical for 25 marks internal practicals and 25 marks external practicals. uh, in overall the scheme for this steel structures is nothing but 150 marks. That means 80 marks university exams, college internal assessment is it is for 20 marks, which carries some assignments will be there for 20 marks. Attendance and assignments will be considered for 20 marks, and again internal practical examinations, there will be 25 marks, and external there will be 25 marks. The overall scheme for steel structures will be for 150 marks. Again, while performing the practicals, so it is no it is not as such a practical room for or practical lab for steel structures. The things which we will study in the lectures, the same designing part or the same designing concepts will be it is to be written down in a record books, and there a sheet to be drawn. Okay, A2 size sheet to be drawn for steel structures. So minimum three design assignments based on the above topics. That means above units. We have to see along with the detailed structural drawing on A2 size sheets. Okay. So these practical examinations will be based on the above practical works. That means in record books we have to write down at least there are 4 units covered in the steel structures. So at least in one unit per unit we will have the one designing concerns regarding one practical will be taken care for each unit. Okay. So in this way, record books to be submitted for 25 marks internal assessment and 25 marks practical external assessments. Okay. Again, in unit number one, there are various things are covered in unit number one. As today is the first lectures, so we will study the in a short way what are the different units covered in the steel structures. What are the different units covered in the steel structures? So in unit number one, steel structures, as steel as structural members, various grades of steel. So we'll see the various grades of steel nowadays, and the different grades of steel it has been available in the markets. So what are the different trends in regarding the grades of steel? What are the different grades of steel which are being used in the construction field regarding the steel structures? We will see, or various rolled steel sections nowadays. Various steel rolled steel sections are also used. So again, it will be broadly studied in the unit number one. The various grades will be studied. The various rolled steel sections will be studied. including cold formed sections, structural pipes, that is tube sections, and their properties will be studied. And again, introductions to IS 800 and 808, that is 816, 875. Nowadays these are the different IS codes. It has been taken care. So we will because designing part of the steel structures totally depends upon the IS codes. Nowadays the most common IS code it has been used as IS 800, that is 2007. So in 2007 it has been revised. So this 2007, with the help of this IS code, that is 800 2007, we will design the various members. We will design the various members in steel structures. The various members in the steel structures. So again, next point is nothing but introduction to plastic analysis. Again, shape factors, plastic hinge formations. Already you have seen in engineering mechanics hinge formations. When the members there is a hinge joint, it has been created. So what are the stresses developed in that hinge joint, or what are the stresses, or the how to analyze that hinge joint. So this plastic hinge formation we will study in the unit number 1. Okay? Introductions to plastic analysis, that is shape factors, again plastic hinge formations, how this hinge formation will be taken care, how what is the effect of these hinge formations, how to calculate the various shape factors regarding the various members, regarding when hinge plastic hinge it has to be carried out. Again, mechanism for the beams, what will be the maximum collapse load while hinge it has been formed, what is the maximum collapse load it is to be taken care. So it has already studied, we will study in the unit number 1. So in this way, again, next third point, it is nothing but the design of axially loaded members. Again, tension members, compression members. So tension members and compression members, already these are the two important members where tensile loads, or when tension members is simple way, tension members are the beam members already, and compression members are the where it has been compressed, that is nothing but the column members. So we will design of axially loaded members, that is the tension members and the compression members. So we will study the different tension members. That means what are the different sections covered in the tension members, what are the different types of tension members, how much load taking capacity of the tension members, how to design the tension members, what are the different members. Suppose we are having different sizes of the tension members. So what should be the size of the tension member, what should be the area of the tension member, whether it is safe to design that particular member, that what should be the shape of that tension members. So all these will be covered in this unit number 1, tension members and the compression members. Again, point number 4 is nothing but the design of roof truss. Already steel members in steel structures, it has been made roof trusses, it has been made with the help of the steel members, steel trusses. So we will design the various members in a roof truss, okay? So design of roof truss will be taken care. Load assignments, whether it is dead load, live load, or wind load. So how to consider the dead load, live load, or wind load, we will consider while designing the various members in a roof truss. Okay? So while designing the members in the roof truss, we will find out what will be the load taking capacity of dead load or live load or wind load. So in this way, unit 1 is very important regarding the introduction of the steel members, regarding the various concerns regarding the various grades of steel members, various types of steel members, what are various shapes of the steel members, again plastic hinges, where it is to be created and how it is to be taken care, and what are the stresses developed in this plastic hinge, we will study in the unit number 1. Again, the tension and compression members, it is very important in case of unit number 1, because the things which we will study in the unit number 1, that is tension and compression members, the same thing will be transferred to the unit number 2 also. Okay? So these tension members and compression members you have already studied in short in mechanics also. While solving the truss problems, you have seen some members are in compression state, some members are in tension state. So we have to design that tension members, we have to design that compression members. In engineering mechanics, we have just we have calculated the intensity of tension members and compression members. That means in kilonewton we have find out the forces in tension members and compression members. But here actually we will design the tension members, we will design the tension members and compression members. Again, last is nothing but the design of roof truss, the load calculations, that is dead load, live load and wind load. Next is nothing but the unit number 2, that is the structural fasteners. Again, we have to combine the different members. Okay, so what are the criterias in combining different members? When two members are clubbed together, or when two members are joined together, so how to join the two members, the what are the different criterias considered, or what are the different parameters considered, or what are the different methods, or what are the different concerns regarding how to join the two members. Okay, so how to join the two members? Okay, suppose there are two plates is there, two angle sections are there, two C sections are there. So how to join these two any two sections? Okay, so in unit number 2, these joining concerns, these fasteners is nothing but to join the two members. So number 1 point in this case is nothing but unit number 2 is nothing but behavior of bolted and welted connections, types, designations, properties, permissible stresses. So while joining the two members, we can join with the help of bolts, or we can join with the help of welds. Okay, so you can all in fabrications works, the welding work, by means of welding we can join the two members, or by means of bolts we can join the two members. So which thing it has been more permissible, whether it is permissible to have bolted connections, or whether it is permissible to have the welded connections, or which will take the maximum loads, or which is feasible to have, whether it is feasible to have a bolted connections, or whether it is feasible to have welded connections. Okay, because in some cases it is feasible to have bolted connections. Okay, you have already seen in the railway bridges also, in railway bridges over the rivers, over the dams, when a railway bridge it has been passing over the rivers, so there is a steel structures. Okay, railway bridge, in railway bridge there is a steel structures. Normally it is a bolted connections. Okay, normally it is a bolted connections. Okay, so we will have a permissible criteria regarding how to build or how to construct, whether it is feasible to have a bolted connections or a welded connections. So behavior of bolted and welded connections, its types, what are the different types of bolted connections, what are the different types of welded connections, or there are designations, their properties, their permissible stresses, how much will be the maximum stresses taken by these bolted connections, or the maximum stresses taken by the welded connections. Again, the most important is the failure works. Okay, so whether failure in the bolted is more, or whether the failure in the welded is more, because the losses, the minimum the losses, the maximum the efficiency, you have already studied in the engineering mechanics. So the minimum the losses, the maximum is the efficiency. That means the minimum the failure, the maximum will be the joint. Okay, the strength of that joint. So again, we will study the failures of bolted connections and the failure of the welded connections. Again, strength wise, we will see the strength of bolt and strength of weld. What will be the strength of bolt? Whether the strength of the bolted connection is more, it is having a more strength than welded, or welded is having more strength than the bolted connections. Because strength plays an important role, because we are constructing a steel structures, so strength plays an important role. We have to maintain the strength as well as durability of the structures. So therefore, in order to maintain the strength of bolted and welded, strength of the welded connections. Again, the efficiency of joints, design of simple bolts and welded connections. Efficiency, as I've already said, the minimum the losses, the minimum the failures, the more is the efficiency. So efficiency of joints, that means welded joint as well as bolted joint. So we have to design, okay, the design of simple bolts and welded connections. Again, the moment resistant bolted and welded connections, or the moment resistant, that means when a load it has been applied, so whether that load will be sustained by the welded connections, or whether that load will be taken or sustained by the bolted connections. Okay? The moment resistant capacity of the bolted as well as welded connections. Again, third point is nothing but unit number 2, design of connections, beam to beam connections and beam to column connections. Okay, so in roof trusses, some members are connected to beam, and some members it has been connected to columns. Okay, so what are the different criteria covered while connecting to beam and column to column? Okay, so beam to beam connections and beam to column connections will be studied in the unit number. Again, unit number 3, design of simple and built up beams. Simple beams and built up beam. What is a simple beam? Simple beam is simple beams is single beams. It has been taken care. So simple beams are that is it has been considered. Whereas built up beams are nothing but when two different beams it has been clubbed together. Okay, so it is to be it has been stated as built up. Built up sections is nothing but the when two members it has been clubbed together to form a single members. Okay, so built up beams. So built-up beams, when it has been singly applied, that is single beam, and when it has been applied in a group, that means it has been taken care in built-up beams. It has been considered as the built-up beams. Again, laterally restrained and unrestrained, that means the base of that beam or the base of that junctions, it has been restrained, or it is unstrained restrained. That means whether it will take the movements or whether it will not take the movements, whether it is safe to take the movements, whether it is unsafe to take the movements, and it has been symmetrical as well as unsymmetrical. Okay, so the in some cases it is symmetrical sections that has been used. Okay, symmetrical sections in the sense when mirror image of the two sections it is same. That means when it has been cut from the centers, the two parts of that section it has been symmetrical. So in some cases symmetrical sections are used, and in some cases unsymmetrical sections are also used. Okay, so what is the strength criteria, or what is the efficiency or the permissible limit of the unsymmetrical sections or symmetrical sections? It will be taken care in this unit number 3. Again, curtailments of the flange plates, design of the welded plate girders. Plate girder, we have to design the plate girders in the steel structures. So, what are the different criteria covered? How to design a welded plate girders? Design of the welded plate girders will be considered. How which things will be covered while designing a plate girders? That means plate girder. It is nothing but while erections in case of a column, the base it has to be designed. The base is nothing but the plate girders. Okay, that welded plate girders it has to be designed. Okay, so we have to consider the plate girders. Again, unit number 4, that is last unit is nothing but again the design of single rolled steel sections columns. Again, you have to design in this case the columns. Okay, we have to design the columns, the single steel rolled columns. Okay, the design of single rolled steel sections columns. So which types of loads will be taken in designing a columns? Already you have seen in railway, that is the foot over bridges, also in railway platforms, also in bridges also. So there is a central column is also there, so we have to design that central column. In unit number 4 we will design that column, the column subjected to axial loads and biaxial moments including base design. Okay, so in this case when a column is taking a axial load or biaxial movements. Okay, so in some cases the column will take an axial load, and in some cases it will take the biaxial moments, and in some cases it will take the both as axial load and biaxial moments. Okay, so we will broadly see in unit number 4 the design of columns while taking an axial loads and biaxial moments. Okay, also we will design the base design. Again, second point related with the unit number 4 is nothing but the design of axially loaded built-up columns and laced and battens. Okay, what is this laced, lacing and batting? Battening is nothing but batten is nothing but the while increasing the strength of columns. Okay, suppose there are 4 columns is there, so 4 sections of columns is there. So we have to joint that columns with the help of bracings. In order to increase the strength of columns, we have to brace that columns. Brace is nothing but we have to club the columns. We have to join the columns, interlink the different columns. Okay, that lacing and battening of that columns, it is to be taken care. Okay, so this will be studied in the unit number 4. That is nothing but the again lacing of that columns and battening of the columns. Okay, in order to increase the strength of the columns. Again, beyond this, we will study in unit number 4, that is the column bases, slab base, gazette base, and movement resistant base. Okay, so slab base also we will design the slab base, gazette base. Gazette base is also designed in this, and the movement resisting bases will be designed in order to take the maximum loads, in order to have the maximum loads. So in this way, in short, in today's lectures, we have studied the, or we have taken care the different units. What are the different units covered in the steel structures? What are the different advantages? What are the different things covered in the steel structures? So in this way, steel structures, design of steel structure is a very important subject related with the university exams also, or related with the sites also, related with the field also. So yes, steel structures is also it is very important subject. So in this designing subjects, we will cover the various things related with the beams, related with the columns, related with the base. That is nothing but the gadget base, also moment resisting base, also how to design the base of a columns, how to connect the various beams, how to connect the beam with columns. So all this will be studied in the steel structures. Okay, so today we will end this introduction lectures. Again, we will have some more lectures on steel structures. So in next lecture we will have different we will have the images related with the steel structures. What are the different steel structures, what are the different trends related with the steel structures. And before ending this lectures, again first important point, you have to purchase, or you have to purchase the IS 800 2007. Okay, so Indian standard code, that is 800 2007 code, it is very essential for the designing of the steel structures. Okay, so IS 800 2007 is very important. Okay, so this code, it is to be studied. Where this is a code, it will be used in designing the steel structures. Okay, so while designing the steel structures, IS 800, that is 2007, it is very important. Okay, so in this way, today we will end this today's lectures. Again, we will have some more lectures on steel structures in next, and we will have some more concerns regarding the steel structures in next lectures. Okay, so thank you.